If you're learning about Google Cloud Security, I have the episode for you. I have Marcus and Marion, who work for Spotify, sharing all things Google Cloud Security over three-part series videos. Basically, there are a set of 4 challenges. Session 2, which is this part. In part 2, Marcus and Marion will be going through challenge 1 and 2. And in part 3, we'll be finishing off with challenge 3 and 4. So overall, with the part 3-part series, you'll be able to get to learn a lot about Google Cloud Security, including GKE, which is the Kubernetes engine from Google Cloud. Marcus and Marian made these three-part series as part of the Advent of Cloud Security by Cloud Security Podcast. So you can also find these videos on advent.cloudsecuritypodcast.tv. But for now, let's enjoy session 2.
Welcome back to the Advent calendar of the Cloud Security Podcast. Today, we will continue with our GCP CTF workshop and dive into the challenges. In the last session, we went over all the details that you need to set up the resources in your own Google Cloud project that you're going to need for the challenges. Just to do a super quick recap, you can find everything that you need in the GCP CTF workshop GitHub repository that we're also going to link in the description. And it contains a challenge setup script that you can run, and it will invoke Terraform and create the resources that you need. So if you want to have more details about that, you can listen to the previous session again. But once you're done with this, you should be at a point now where in your own Google Cloud project, if you go to the Kubernetes engine and then on the left to clusters, you can click on the cluster here that got created via Terraform. It's called GKE Cluster Challenge 1. I'll click on mine here, and then further down in the control plane networking section, you can grab the public endpoint of this cluster. So copy this IP address and save it somewhere because you're going to need it later for challenge 1. Also make sure to copy the public endpoint and not the private endpoint. And if you would destroy this cluster with Terraform because maybe you took a break and you want to come back to this workshop later, then make sure to copy it again because when you recreate the cluster, it might get a different IP address. All right, so now that I have this, I am completely done with the setup of this workshop, and I can now dive into the challenges from a CTF participant or attacker point of view. In general, we have to do a bit of a perspective switch for this workshop because until now, we've been busy with all the setup. And of course, the project that we're using here, you own it, so you don't really need to gain access to it, attack it, or exploit any vulnerabilities in it because you have access anyway. So now we're going to do this perspective switch and imagine that we are a CTF participant or attacker and we don't have any access to this project. And the best way to simulate that is if you actually use yet another separate Google account. The important thing, though, is that this does not have to be a Google Cloud account. Any Gmail account that you already have, or you can also create a throwaway Gmail account for this, will work. And that's also what I did here. So in this browser window here, I'm using a private session so that I don't mix up my Google accounts. And here I'm logged in with just a totally separate Gmail account that has nothing to do with Google Cloud. So if I would try to access the Cloud Console here now with this account, it would tell me, hey, please sign up for GCP because this account does not own any project. And this way, you can avoid confusion and you can actually see if you really solved the challenge because you know that you exploited the misconfiguration and you're not wondering if you just gained access because you own the project anyway. So we recommend you to do this. I think it will make the challenges a bit more enjoyable. So once you're done with that, we can jump back to our GitHub repository and now actually really get started. All right, so let's take our attacker or CTF participant perspective and get started with challenge 1. I went back to the repository into the hints folder and I opened the document for challenge 1. And now we will walk through the introduction section here together. Most of the commands that I'll show you are also in here, so you can try everything yourself. As a starting point, all I have is an IP address. And that is the IP address of the GKE cluster that we copied earlier. However, I, as an attacker, don't necessarily know that this is a GKE cluster that's listening there. So my first task might be to just play around with this IP address and see what's listening and what I can find out. The first thing that I'll do is to set this IP address as an environment variable in my terminal. And that is just to make my life easier so that I don't have to type it all the time. And you can then also easily copy paste all the commands that we have prepared for you here, because it also just uses the same environment variable again. So I did that. And you can do the same and then, of course, use the IP address of your cluster. If I would run a port scan with Nmap, for example, against this IP address, I would find that it is a Kubernetes cluster and port 443 is open. You can try that as well, but you don't necessarily have to. Port 443 is so common, so you might have also just tried to access it directly with curl and see what response you get. However, curl gives us an error message. That is because we spinned up this cluster in the completely default configuration, and it comes up with a dummy certificate that is not trusted on your machine. However, for the purpose of this workshop, we don't care about that, and we supply the -k flag to curl to tell it to ignore the certificate error and still give us the response. And we can see that it is a 4 or 3 forbidden, so we can't really do much here. And it tells us that we are system anonymous, and we are not allowed to access this endpoint. There are a few endpoints that you can access though. For example, you can access the version endpoint. This is the default on GKE. If you just spin it up and you expose it to the internet, then everyone could access the version endpoint of the cluster. And that could be helpful as an attacker. For example, if you might run a super old version and there would be a known vulnerability against it or anything like that. However, in our case, this is not an old version and it does not really help us much as an attacker. So we need to improve our situation a bit. And in our introduction, we are giving you some more hints how you can do that. Because besides the system anonymous group, there's also a different one, which is called system authenticated. And system authenticated on GKE is interesting because you can be in system authenticated just by supplying any Google authentication token. And it does not necessarily have to be the authentication token of an account that belongs to the organization owning this project or anything like that. So just supplying any Google authentication token will put you into the system authenticated group. So let's give that a try. First, to demo how it looks like now, if I would just try to access the API endpoint, for example, I would get the 4 or 3 forbidden. So let's try to get a token, and then we'll try that again and see what response we'll get. So if any token for any Google account is going to help us out to become system authenticated, then how do we get a token for our own Google account? And one easy way to do that is to use the OAuth Playground. The OAuth Playground is a website by Google. I'll open it here, that you can use to authenticate against different Google APIs and get an access token. You need to be signed in with a Google account here to use this, and I am signed in here with my attacker Google account, so the one that does not have any kind of access to the GCP project. Then I would have to select first the correct API or correct OAuth scope that I want to use. And this is the Kubernetes Engine API v1 that I'm going to select here. And I would click on Authorize APIs. It will pop up an OAuth flow that I have to accept. And then there is a next step that pops up where you can exchange code that you get for an access token. And once you do that, you can find your access token. For me, that is this one here that I'm going to copy now. And I can show you the access token also in the video because it will be expired by the time that you see this. And to make it easier for me to use the token in the next commands, I'm also going to set it as an environment variable again. So once that's done, I can copy paste the next commands in the introduction again. So before we tried to access the API endpoint of the cluster and we couldn't because we got a 4 or 3 back. So let's try it again now, and this time we will supply the token that we just got as an authorization header with curl. So I'll copy that, call the endpoint, and yeah, we will actually get a response now. So that's pretty cool. Just by supplying any access token, I will get a different response because now I am part of the system authenticated group. Now, by default on GKE, you can do that, but the system authenticated group also doesn't really have many interesting permissions. So just by doing that, you can't really gain access to any GKE cluster out there, at least not if the GKE cluster is configured correctly. But our cluster might have a misconfiguration, and maybe someone allowed the system authenticated group to do more than you could do on a normal cluster. One thing that you can do, though, on this cluster as well as on any default cluster is to check which endpoints you can actually access. And to do that, we have a pretty long command that you can copy from the introduction section, which is this one here. I'm also going to copy that. And you could, by the way, do that same command also with kube control. There is a kube control can I command to check which kind of resources you can access. That would do the same thing. It would use the same endpoint as this curl command here. But for this workshop, we thought it's easier if you don't have to configure kube control. So we will just give you the curl endpoint to do that here. So if I use this, it will tell me what I am allowed to access. There are a few endpoints that I can access that I already know, for example, the version endpoint that we saw before, but there is more. It tells me that I'm allowed to do the self-subject rules reviews call that I just did. That is the one that is telling me what I am allowed to access. But I can also see that on the namespaces in this cluster, I can access a few resources as well. And that might be something that this cluster admin of this GKE cluster configured for some reason. So let's try this out. And I can, for example, as this command shows me, I can access the pods endpoint. There are no pods here, so that is not very exciting, but maybe I can access other resources as well. And here we will give you some time and you can pause the video and see what you can find out on the cluster. And your goal is to figure out what other secrets this cluster might have in store for you. Okay, so now let's do a walkthrough of challenge number 1. We hope you had some fun experimenting with the setup and that you found the flag and also what secrets the cluster has in store for you. So let's do the solution together now. So we had before in the introduction figured out that once we are in the system authenticated group, we can use this endpoint to see which permissions we have on the GKE cluster. And we also found that this cluster is misconfigured and it will give us access to the pods, but also the secrets that are in the default namespace. So pods we checked and there were none, but secrets, of course, sounds really interesting. So let's take a look at the secrets on the cluster. We're going to use the same endpoint that we used for the pods, but then we're going to check for secrets instead. And yeah, indeed, we can access the secrets in the default namespace. There are 2 secrets. The first one is called flag1. So that indicates that we are on the right track to the solution here. And the other one is called GKE app file uploader account. Let's take a look at the value for flag number 1 first. By default, the Kubernetes secrets are base64 encoded, so they are not encrypted or anything. It's just a base64 encoding. So we can check what the value of this is, and it says you found flag number 1. So congrats if you made it to this point. And additionally, let's take a look at the value of the second secret. Copy this long blob again, and I'll decode it in the same way, and it will give me this blob of JSON. This is actually a service account key that someone exported from GCP. We're going to use that in the second challenge, so we recommend that you just store this in a file for now so that you can use it later. And let's take a quick look at the values in this JSON. So first you can already see the project ID of the GCP project. So here you can see mine, but on your JSON blob, you will see your project ID. And similarly, you can see the name of the service account here in the client email field. So this one is called GKE app file uploader. The name of the service account might already give you as an attacker some hints what this application might do. But the most important part for us, of course, is the private key that we have in here. Because with this credential, it allows you to authenticate against this GCP project as the service account that has this key. So for challenge 2, we are definitely going to leverage that. Also, of course, this private key will be invalid once you see this video. All right, so before we move on to challenge number 2, let's do a quick recap of the key learnings from this challenge. First of all, we had the misconfigured cluster, where our cluster admins unfortunately did not interpret correctly what the system authenticated group means, and they gave it too many permissions. So it's really easy to misunderstand that system authenticated does not only include people of your organization who might have an account with your company, etc., but it actually includes everyone with a Google account. So basically everyone on the internet. And in our Markdown document here, we also have a link down here to a write-up that was done by Orca because they published some research in the beginning of 2024 about exactly this misconfiguration because it's an easy mistake to make. And in here, they found that a lot of GKE clusters that they found exposed to the internet even had the cluster admin role bound to, for example, system authenticated. So you're basically giving anyone on the internet cluster admin, which is really probably not what you intended to do. And Google has reacted to this. And now it is no longer possible to bind the cluster admin role to system authenticated. But you could, of course, still misconfigure your cluster in the way that we did and bind a different role and different permissions to it. There is also a really similar IAM group in GCP. I'm jumping to the GCP docs here to show this a bit better. This is called All Authenticated Users. And that is basically the same thing, but for GCP IAM. So if you would create an IAM binding to allow someone to use a GCP cloud resource, and you would bind this to the group All Authenticated Users, then again, you would bind it to everyone with a Google account. So yeah, one learning is be really careful when you use all authenticated users in GCP IAM or system authenticated on GKE, because it can really have some consequences that you might not have intended. And the second thing that we want to highlight is the credential that we see here. So this is a service account key. And service account keys are not really needed as much anymore nowadays. And we would also recommend to avoid using service account keys whenever you can. If you create a new Google Cloud organization now, there is even an org policy enabled by default that disallows the creation of service account keys. And also, if you have an older organization, you could enable this organization policies to stop people from doing that. The reason is that these credentials, they are really hard to manage correctly and keep track of. Someone might accidentally check them into source code repositories or lose them somewhere. And you can't really know if someone who's using this service account key is really supposed to have access to it or not. And by default, if you create service account keys, they're also valid forever. They don't have an expiration date. You could set one, but the default is that they don't have one. So yeah, if you don't really have to use a service account key, then don't do it. And if you have applications within Google Cloud talking to each other, you also don't really need this at all, because Google will handle the key management in the background for you. And even if you have on-prem applications or applications from other clouds that need to talk to your GCP resources, you don't necessarily need a service account key, because you could use workload identity federation instead. So it's a bit of a legacy credential that we will hopefully see less and less, but there are still a lot in use right now, and they are really easy to create. So yeah, if you can, we really recommend to avoid it. But for us as an attacker, this is of course great. And then in challenge number 2, Marcus will show you what you can do with this service account key.
Hi everyone, and welcome back to this episode of Advent Calendar for the Cloud Security Podcast. In the last episode, Marian showed you how to get access to the insecure GKE cluster in Challenge 1 and read the secrets from the cluster, in which you were able to decode the base 64 secret that turned out to be a GCP service account key. Now, in this challenge, Challenge 2, you will use those credentials to get more access to the GCP project. And I'm now going to walk you through the challenge and show you how to do it. Now, what we want to do first is to make sure that you have stored the service account key file locally in an easy place where you can find it. We're going to start by exporting the project ID as an environment variable, because we're going to use that for later. And then we're going to use this command here to basically impersonate the service account using those credentials that you have obtained. So let's do that right now, and then I'm going to walk you through the rest of the steps. So first, we're going to export the project ID, as you can see here. And what you can also do is to make sure that in the service account key file that you have stored locally, in my case, I have stored them in the desktop folder right here. You can see by looking into this file the project ID. So to show you that very quickly here, you can go and do a basic cat command here and find the project ID this way. Here you also have all the other information from the service account key, and also make sure that the JSON format is well structured here so that you don't have any problems with indentation or other issues. So now that we have exported the project ID, we're going to use the command to impersonate the service account. So simply copy the command right here. And in my case, I mentioned that I have stored it in this path. So make sure that you replace this path with whatever key or path you have to it. Now, also make sure that once you execute this, that you see the following output. So as you can see here, we have now activated the service account key credentials. And by doing so, we have effectively impersonated the service account. Now, the next steps is that we want to make sure if we can see to gain more access to data in the project. And I'm now going to walk through the solution for how to do that. So if you want to try this out on your own first, please pause here and start your own testing. And if you haven't already, I'm going to walk you through the challenges here for you to see. So as you can see in this hint, we have included a bit of telling factors here for it. We're now going to walk through the solution to challenge 2. So if you look in the repository, you can see that we've included a reference to the command gsutil_ls. This particular command lists all of the cloud storage buckets in the GCP project. And since we now have the permissions of the service account, let's see if we can see any of those buckets in the project. So if we go to the terminal and we try to run this here, we actually see that we get an access denied with a message that tells us that this particular service account does not have the needed permissions to list all of the buckets in this GCP project. Now, this is a good thing because normally you do not want a service account or other identity to have these very general permissions to list any resources, etc. So how do we then move on and solve this for challenge 2? If we go back to the repository and look at the first hint, we can actually see that we've included a reference from challenge 1 telling us that a particular label might have the name of a storage bucket. So that's very interesting. So let's go back and see in the terminal here, using the curl command we had from challenge 1, if we can find a label that mentions anything about a bucket. So here we have the service account key that we decrypted using base64 decoding. And what we now want to see if there's any labels in here that we can use. And I'm simply going to search for the string label in here to see if I can find anything. And you can see that we have 3 matches for that string. Now, the first one doesn't really tell us much. So if we go up here a bit, we see actually for the first match, we have a naming reference for a storage bucket. Now, this name and the bucket reference is not that uncommon. It happens that you include metadata of this type to link resources together. It's, however, a partly dangerous thing to do because in this case, as we are an external attacker or entity, if we get access to these secrets that are part of the cluster and read out this bucket reference, we now have more information about resources in this project. So with this bucket name now, let's see if we can actually see if we can list the files in that bucket. So if we then try to use the gsutil command again, but we add the name of the bucket, we actually see that there are 2 files in here that we can read. Now, secondly, let's see if we can see what those files contain. So in this case, we're going to use the cat command to list the contents of this file, which we now can. And as you can see here, we have found flag 2, which is great. That's what we want to do. Now, lastly, we're going to see if we can see the contents of the second file here, which appears to be a Terraform state file, which we also can. So this is great because Terraform state files contain all of the resource information used to create the Terraform configs and plans. And with this now, we can actually move on to challenge 3, because this was the total files that we wanted you to find in challenge 2. And just to do a quick recap, what we have learned. So we saw that using the permissions of the service account, we were able to not list all of the buckets in this project, But knowing the name of a particular bucket, we saw that there was permissions in place to allow the service account to list the files and the file contents of that particular bucket. Now that we have found the Terraform state file, you have all the information you need to proceed to challenge 3. So as you saw, this was a bit quicker challenge than challenge 1, but hopefully you had a good time solving this, and good luck in challenge 3.